QuantSpeak, expert insights from quants for quants.
Welcome to QuantSpeak, a new podcast from the CQF Institute at Fitch Learning.
Hi, I'm Dan Tudball, editor of Wilmot Magazine, and this is QuantSpeak. On the 14th of June, the CQF Institute will present a one-day conference to mark the 50th anniversary since the first publication of the Black-Scholes model. That's going to be at Eastern Time, and if you're a CQF Institute member, you should really sign yourself up now for that one. Dr. Jörg Kienitz is a partner at Quaternion, Acadia's quant services division. Jörg consults on the development, implementation, and validation of quantitative models. He's an assistant professor at the University of Wuppertal and an adjunct and associate professor at the University of Cape Town. Prior to joining Quaternion, Jörg worked at firms such as Reuters, Deutsche Postbank, Deloitte, as well as teaching at Oxford and other institutions. Jörg has authored 4 books: Monte Carlo Frameworks with Daniel J. Duffy, Financial Modeling with Daniel Wetterau, and Interest Rate Derivatives Explained 1 and 2 with Peter Kaspers. He's also co-authored many peer-reviewed research articles that appeared in leading journals, including Wilmot Magazine. Welcome, Jörg.
Thank you very much for the introduction, Dan, and it's great that I can join this QuantSpeak period, actually.
I wanted to talk about first, the way in for us here is we've got the anniversary of Black-Scholes coming up. It's interesting because we're actually celebrating Black-Scholes and not Black-Scholes-Merton, although Merton's contribution is the one that takes it into the really probabilistically relevant kind of realm. And in terms of practice, that's what we deal with now. But it was just interesting to kind of mark this particular publication in terms of its formalizes what we have come to recognize as the options trading industry. It has it made that concrete in terms of how we think about things. And then obviously when Robert Merton made his contribution, then in terms of being probabilistically more viable as a usable model, then that's where we really kick off. But in terms of the presentation that you're making, Hedging in the Age of Statistical Learning, it's right up to date in terms of where quant finance is at the moment. This is really at the sharp end of where quant finance really examines these problems now. Can you tell us a little bit about the relation between the work that you're presenting at the conference and how this ties in? Maybe we'll end up at a point where you can actually talk about Black-Scholes hedging. So let's kick off from the machine learning starting point and then take us through that to hedging in Black-Scholes.
Yeah, sure. So first thing, I think you mentioned a very important thing, namely the name Merton, actually. And during writing the books, I experienced from one of the reviewers, actually, he was very happy that in the books we always mentioned Black-Scholes and Merton and BSM. So not forgetting just one of the key figures, I think. And also in the slides of my talk, which I'm presenting, at the conference, I mentioned Black-Scholes and Merton, though it is the 50th anniversary of the Black-Scholes model as it is announced. But nevertheless, so for me, actually, the key idea in this whole framework of Black-Scholes and Merton is the idea of being able to use a portfolio of certain instruments, namely riskless account and risky underlying stock, for example, and form a portfolio in a way such that it is so-called risk neutral, namely that it earns the rate which you can earn just giving your money into a bank account, for example, or buying a riskless financial instrument contract whatsoever. And yeah, that is very interesting. So despite that the stock price or the risky asset price has a certain kind of drift in their framework, it is actually safe for evaluating an option to use the risk neutral rate for deriving all the equations or the underlying option prices. And this is due to this hedging argument. And that's a fascinating thing, I think, because the kind of idea can be applied to much more general models, to much more general settings, actually, getting rid of all the underlying assumptions in a way, just by specifying a possibility or a way to hedge. And this is the key idea of the talk. And it's based on earlier works I did with colleague Gordon Lee. He's now at BNY Mellon, and a former colleague of mine, Nikolai Novacek, and Nancy Gang, a former student at Imperial College. And we considered the idea of specifying model agnostic and data-driven delta hedge. And in this respect, we introduced local regression, kernel estimates, so really nitty-gritty numerical techniques for being able to derive not only the prices, but as a byproduct, the hedges. And within this numerical setup, we had to determine which is called, for example, the optimal local bandwidth in this hedging procedure. And this is a numerical delicate problem if you deal with others than the Gaussian distribution, for example. And the key idea I am presenting at the conference is that I'm specifying a hedging strategy and implicitly a pricing, or a price implicitly a hedge, see it as you like. And just using a discrete time grid, so hedging takes place in a discrete time, where I only have to know the realizations of the underlying assets at these time points. And to keep things simple, I thought not having this numerical complex computation of local bandwidths in this setup, but it would be nice to simply specify a model class and just one parameter. And actually, that's what I do with the Gaussian mixture models there. So the acronym GMM stands for Gaussian mixture models. And these Gaussian mixture models need just one component, namely the number of Gaussians which you mix in terms of the distribution, not in terms of the sum of random variables there. Yes, and with this setup, somehow you can handle quite complex distributions. So bimodal distributions are possible, distributions where the tails are not that of a Gaussian, they can be skewed, and so forth. And the only thing then would be to determine the number of Gaussians. The other parameters which go in there, like the means and the covariances and the mixing weights, are derived by a very standard numerical approximation procedure, which is called the expectation maximization algorithm. It's very well known among statisticians and mathematicians, and there have been a lot of research of making that stable, determining the starting values for the optimization and so forth. And once you have specified this, the number of Gaussians, you simply use your data, fit the Gaussians to the data. And the key point then is, once you have these Gaussians available, you are able to compute, due to the nature of the Gaussian distribution, all conditional distributions analytically. And that's quite nice. So in this talk, I will present how you can use this numerical expectation maximization and the properties of the Gaussian distribution to then be able to compute the deltas and finally also the prices analytically. And you do not have to worry about the underlying model in a way. Once you have the Gaussians set up, you are in business and can calculate everything in closed form. And for that, I show the application with the models you mentioned already. So, for example, the Rath-Bergomi model. So it's by no means Gaussian, actually. And the deltas and the prices had to be computed with Monte Carlo simulations, and that's of course time consuming, but with this approach we can apply this GMM model to this kind of model, for example, and be able to get the deltas in closed form. And the same holds true, for example, for the Heston, the Bates model you mentioned, and presenting some stuff in one and in multiple dimensions, so a 10-dimensional Heston model where we calculate the deltas in closed form. So that's something I think which might be very interesting to the quant finance audience. And with
Absolutely. How long was the paper in development for? Because it's very, very involved.
Yes, it's actually based on the ideas I've set on using the local regression stuff with Gordon Lee. And then it was only actually a small step to think about what type of methods you could use to simplify everything. And then I came across the Gaussian mixture models. I had dealt with them sometime in the past and found it very interesting, actually. So to parameterize smiles, for example, and so forth. And I used them actively once I was a quant in a bank. So I came up with this idea, tried it out, and these fantastic open source, maybe another topic for this QuantSpeak today, open source libraries which are available in the Python package. They provide nearly everything you need for that, and the things which were missing were easy to program, actually, when you, of course, can handle the underlying packages and know what you want. Then I applied it actually to the Heston model at first, and it worked quite well in one dimension. And then, once you know where you have to look, where you have to tune things, you can get results very fast, actually. So putting then the examples together that was not that complicated, and it worked really quite well. But I think the complication now becomes in taking the idea of the initial application and spreading the method to other types of problems. So with a student, I'm currently investigating forward-backward stochastic differential equations. We got some nice results there, and these are quite involved topics in mathematics and in quantitative finance. And I can see some interest from other disciplines and other applications in quantitative finance where we are currently looking into. And I hope that this method somehow will be investigated further, researched further, and maybe we'll find some nice other applications for that.
Yeah, that's great. I look forward to seeing the results of the new work, the new research that you're working on at the moment too. One question that I'm curious to know what you think of this. With machine learning having become so much of a accepted tool now at this point, it sometimes makes me recall when I first had to become familiar with quantitative finance, which was at the turn of the millennium, so we're going back some time now. And at that point, I recall it was quite easy to discern Some researchers were very much about statistical methods. Some researchers were very much about numerical methods. And sometimes they'd get into terrible arguments with each other. Largely, of course, I'm sure because of the technological limitations of the period. But now we're here and we are here. We've gone through the evangelizing of big data. We've moved into the machine learning era and the associated artificial intelligence issues as well. And I was just wondering whether you might reflect on whether machine learning has sort of represents a form of victory for the statistical approach, if you will. What do you think?
Yeah, that's a tricky one, actually, because I think one thing, you mentioned the computational power. That's, of course, one key reason for the success now, because also in the for the statisticians, I think there are these frequentists and these Bayesian guys somehow. So with the advent of the computer power, I think Bayesian methods, which are somehow really the idea to think about data, as I would frame it, actually. So having a prior distribution where you put in maybe some expert knowledge, maybe you do not have any knowledge at all, so you're just assuming a given distribution, but then you're collecting data. Data flows in and you can update your prior distribution and account for the data to make it into posterior distribution. So I think this is something where you need a lot of computational power, and these Bayesian methods are somehow a real key of these statistical learning methods. And actually, this is also something maybe not explicitly mentioned in this talk, which I'm going to present at the Black-Scholes 50th anniversary conference, because it's all about conditional expectations, like this prior and posterior distribution. In between lies something where we use conditional expectations. And I think this is one key thing. And I at least had in the beginning, some trouble, some problems to really get my head on into these conditional settings. So I remember when I first heard about that at school, this the base rule and how you can apply it, and you get some nice examples where you in the beginning did not really have the right feeling what's going on. So it was something which was a kind of magic for me. But once you get into that and accept this conditional expectation thing, this conditional probability thing, I think it's quite powerful, and now it's actually accessible with regard to the data size, the data availability, the computational power, and so forth. And I think this will sooner or later also be applied anywhere, I would say, in the one or the other way. Of course, in quantitative finance, we might face two different, not teams, but two different sides, actually. One is very, very regulated. So if you think about risk management, and you have to include the auditors, you have to include the central banks, you have to include the authorities and everything. And on the other hand side, of course, you have like funds where they want to seek certain trading strategies. And of course, they are keen to apply this type of ideas using alternative data and so forth. If they have some nice ideas, get trading signals whatsoever, and they generate some profit with that, I think, that's quite nice and fair somehow. And also, I think for applications within middle office in the bank, if you want to use it for data cleaning or outlier detection and so forth, I think it would be good if you can identify outliers and then just work on the data and come up with clean data series for time series analysis, for example. And nobody tells you you do not have to use or you cannot use machine learning type of applications or statistical learning applications. But if you go to the authorities and want to have an IMM model for counterparty credit risk or something, and you say, oh, here, I throw some machine learning techniques, some deep neural networks to something, and let this machinery do its job, I think they would not really approve it. And that's something, I don't know, this is under development, actually, to get some of the ideas in a different setting. So maybe as a kind of tool inside, or something where you can use it for calibration exercises, for example, and maybe there are ways of making this more mainstream also in the risk world, I would say. Maybe there are some techniques in the future for assessing somehow the stability of these methods. We are looking into this explainable AI world. I think there has been a lot of progress in explaining certain techniques, and there are many people who really force to use these explainable AI techniques in quantitative finance. I'm very curious what the future will bring. There are certainly applications for the quantitative in the quantitative finance field for this, but there needs to be some more work actually on how to explain it, how to assess the stability of these methods, explain why and how it works, and yeah. So I think it's just a matter of time when we see more and more applications of machine and statistical learning in areas where currently I think the hurdles are quite high, and the methods or the application of certain methods is quite restricted.
Yeah, absolutely. Actually, going back to your presentation, utilizing GMMs, being Gaussian, I mean, how in that kind of framework do you deal with outliers, actually?
In this framework, so when I consider the data which I'm using as an input, I actually assume that this is a type of clean data. So for the examples, I'm using data which is generated from the stochastic models. So of course, they could be flawed. There could be outliers if you use, for example, the wrong Monte Carlo simulation method for the Heston or for the Bates model. I think that is not really appropriate. And in real life, so for example, I also present some applications of synthetically generated data by using variational autoencoders or quant GANs, so the generative adversarial network type approaches. You have to account somehow for how the data looks like. It's like in a linear regression, I would say. If you apply linear regression in the very, very easy setup for pricing a Bermudan put option just on one stock, using GBM, for example, and have a very long dated option, you face the problem that the GBM generates quite large range of values, actually. And if you simply use the linear regression with polynomials degree 2 or 3 somehow, and just throw it to the data, you will see that the results might not really work out. So you have to adjust your basis functions. Maybe you have to restrict the data to a certain interval somehow, and ask yourself if some realizations of prices beyond, I don't know, very large numbers are really feasible. But on the other hand side, if you cut off somewhere, you would implicitly destroy the distribution. So of course, there are always some types of techniques you have to apply for making these methods work. And in examples I present, actually, I'm not caring for outliers, but once you have specified, for example, from real life data, the valuation of the GMM in a way that you calculated the weights, the means, and the covariances to have your GMM model, it's not only something where you describe the data, but it also has the potential to generate data because you can sample from a GMM model in a way. And that's also quite interesting because what I could do actually would be that I can take a universe of stocks which are available, for example, for a certain time period, have their common distribution in terms of the Gaussian mixture model. And if I now want to have one realization of one of the constituents at a certain value, I can condition on all the other variables in a way. So having, say, for example, a 10-dimensional Gaussian distribution, and I want to keep 9 of these fixed and just want to sample one under the assumption that I know the distribution and the realizations of the other 9, I can generate this just one realization there, and that's quite fine because of quite nice, because one can use it in conjunction with bridging techniques for imputing data, and maybe also for forecasting or backcasting data in a way. So having a kind of conditional backcasting mechanism, which might be very interesting in setting up risk systems, or for, I think, exchanges where they have to somehow backcast time series into the past for some new companies which are now listed on an exchange, for example, and there is no data, or for certain interest rates maybe that are newly introduced, and where you just have only a small time series, but you need to provide, I don't know, a time series which is 2, 5, or even 10 years long. So I think there are some potential applications in that as well. So being able to conditionally generate data, like using the GMMs or conditional variational autoencoders, conditional GANs. So conditional distributions, I think, are very, very interesting and have a great potential, not only in pricing and hedging applications, but maybe in real life applications for people working with market data. So to just backcast time series, impute missing values in time series, and so forth.
I feel reassured. Thank you, Jörg. You were talking about the part that open source software played in the process of doing the paper. This is a very important area, I feel. I mean, what are your reflections on having that community, the openness of it? This is something that will also lead on to a little bit of talk about the collaborative process as well, and what's important in terms of research. But yes, I mean the role that open source played in this for you.
Yeah, so open source, I think it's a very important part of the software business actually, and people use it in the area of statistical and machine learning all over the place. So we do not want to talk about Python and all the packages, or R and all the packages. I think this is a quite well-established open source community. But I also like using quantitative finance libraries, like, for example, Luigi Balabio's QuantLib, or our contribution at Quaternion or Acadia with the open source risk engine, which is based on QuantLib actually, but providing a kind of risk management application framework interfaces to assess the QuantLib classes and extend, of course, the functionality there. And what I like actually is that you do not have to really rework for doing research in real life all the, say, standard models again and again, and implement a PDE solver, implement a Monte Carlo simulation engine, and so forth, or for the 276th time the Hull and White model, because it's somehow in there and it's accessible and it's open source. So whenever you have to document it, you can just show the source code if you want, and documentations and so forth. And it's also a nice collaborative tool, because if somebody has a new idea, a new method that can be used or is important for the community, one can release it into the open source, either add it to, for example, ORE or QuantLib, or just make it available. So I think that's very important also to spread the ideas in terms of applications. I think it would be nice if people have the access to the code which you use to produce certain figures in a paper, for example. I think it's just a way of making the contribution a good idea for a certain task more accessible, and people I think like that, because it's sometimes hard to understand the theory, then sit down, do all the coding from scratch and so forth. So I think that's a really nice thing. And yeah, there are some open source projects. I mentioned ORE, I mentioned QuantLib. There's also a nice library in Java from Christian Fries called FinMatlib. He has a lot of nice models implemented, a well-designed setup for that. And yeah, so I think there are some open source sources which are accessible to the community, and people can experiment with that. And I'm sure one can find a lot of diamonds in there and use it not only for quantitative research in universities or in the quant labs, I would say, but also actually in real life applications. So
spiritually, it conforms with the scientific ethos, doesn't it, of open collaboration and so on, spiritually. And there's a certain irony that we're dealing with one of the most secretive industries in the world in terms of how people are doing things. So it's an interesting tension there. I think that another sort of side of this particular diamond is also publication of research as well. The open access ethos with in terms of quantitative finance research, a lot of researchers very much lean on releasing their work now through archive and other such open access repositories of work. But the one of the questions for me is about sort of completing the circle in terms of the aspect of it that might be missing is the peer review, right? How do we deal with that? Do you think that there's still an important place for publications with peer review, or do you think that it's going to be an area that also is going to be revolutionized as a result of the access to technology, the platforms that are available, and so on?
That's a tricky one, actually. I think the peer review is a very important part of research, because it should somehow guarantee that the research which is published has certain quality standards. And it's also good if you're getting the feedback. So the peer reviews I was involved in somehow would really be or led to very good final results in the paper, because everybody reads it in a different way. Reviewers come back and ask you for clarification. Sometimes, of course, they challenge you, which might be a little bit tedious and bothering, because you have to provide new examples, you have to run it on a certain type of data set they suggest. In the end, actually, it somehow makes the contribution better. It's maybe you're realizing that the initial methodology you provided or the algorithm you used is not stable enough. But once you reacted on the reviewer's suggestion, you see where you can improve your methodology or your paper. And I think that's very important, because in this setup using the possibilities like archive, there's often not that great response, or often you do not get feedback on that. And I think the reviewers, maybe sometimes they are too critical, but I think you can always write your rebuttal and defend what you have written, actually. But I think overall, this process is very important, and it improves the research. It improves upon your ideas. You reflect yourself, and I think that is something the quant and the research community does not really give up, actually. And it's also an honor if you hand in your manuscript to a great journal, and after this long review process, maybe also a short review process, if it's already well written, go through. It's a kind of real honor to have some publication in a very well respected, peer-reviewed journal, actually. And it wouldn't be the same if you just have put it on archive and people like it, but having it into a nice, well-respected journal is something different for the researcher, but also I think for the community, they do more profit on that. But I like also the idea, early stage research and method you make available on these portals, and people immediately know that there is something written on that, and maybe it's a source of other researcher picking up the idea and making a great contribution out of it that afterwards appears in a journal, for example. So I like both ways, but I think the peer review process will stay in place, and it's very important to have it.
Absolutely. I keep telling people that too, but obviously I'm biased.
Of course.
You know, you've had varied experience through the industry over the years, both as a practitioner, as an educator, as a researcher, and as a consultant. So, you know, an interesting question to put to you, I think, is the structuring of teams, the fitting into teamwork, the importance of this kind of collaboration that we're talking about once it's brought down to that pinpoint, which is the team that is executing, whether it's research, whether it's trading, whatever. In your experience, what have been the most important factors for you in terms of establishing yourself within an existing team, and then also defining what is needed to develop teams as well?
Yeah, so for me, I think I was always in a position, luckily, I would say, to only have small teams, actually. So I started with leading a team in a German bank, which I really set up from scratch. And in the end, there were 5 people, so not very big. And later on, I led teams within the Quaternion and Acadia setting of up to 10 people, 10, 15 people. And there, I think you really know all the people in the team. And I think that's very important, because then you can recognize certain skills, certain people, and also honor these skills and people. That holds true in professional life, but also in research. So let me give an example. So in a research collaboration, for example, you're gathering the ideas. There might be some people who really have an intuition for setting things up. but they are very sloppy in writing things down. But there might be other people who can then grasp the ideas, the intuition, and produce a really nice formal proof, a formal way of writing this down and putting the words together, make it into a very nice presentation, into a very nice exposition. And other people then are engaging in the project, also understanding, contributing, but then in a kind of validation procedure to really read the paper from start to end, and then tie everything together so that the success for back again for this peer review thing, that the success rate of handing in the article to a journal and getting it accepted gets high. And in professional life, I think it's the same. Some people are more introvert. They do maybe the coding, writing reports, putting everything nicely together. And there are others who then can take the ideas and present it into and go into committees, present it there, can really handle with answers. They can quickly react and so forth. And I think that's very important. So I was very lucky in my career, so that the teams I had or had to manage worked very well, and all the people accepted how the other people worked, and I think everybody found its role in the team. And we were lucky to have really all the different characters. So some people are a little bit sloppy, but very intuitional, sensitive, and they could really grasp problems very fast. But on the other hand side, there were people who then really structured the ideas and laid them out, worked on documents really with a nice outline and structured, and somehow supported then the work of the people with their intuition. And also, luckily enough, we had always the people who did all the coding, very large high coding skills, which they could apply in different languages. So that was really nice, because I think not only the theoretical side and assessing of regulation of topics and ideas is important, but also then taking the ideas and producing code from which you then can produce numbers and check if everything is in line and right. And so we always had a very good mix of all the people, and as an add-on, all the people were able to code and produce these numbers and figures out of the ideas and the underlying data. That was very helpful.
Absolutely. The coding aspect of it actually sparks another question for me, but I'll save that for a little bit later. A lot of our listeners, of course, are on the CQF program, have been on the CQF program. It's about career development. They're looking to work their way up the ladder to a managerial, to a head of department type role. And given what you've said, would you say that there are any particular things that a person can work on in terms of making themselves more prepared for that responsibility of managing a team of diverse skills and diverse interests? What sort of mindset or characteristics ought that person cultivate?
Yeah, so I think that's an important question and not easy to answer, actually. So I think, first of all, I think you should get a good idea of how the team is structured, how it works, how it looks like, how the mindset in the team is. And I think then implicitly, maybe also as a kind of intuition, you approach a person, an applicant for a certain position in this way. And I think it's very important so that you not only look, of course, into the CV with all the skills he could provide and assess programming skills, assess quantitative skills, math skills, and so forth. I think it's very important, of course, but it should also be assessed by, can this person be a part of the team, and where do one sees the position of this person in the team? And I have always felt very lucky, because I had the teams who wanted to get introduced to the possible new hire. We afterwards discussed if somehow this type of character, this type of person would also fit into the team. And I think sometimes it's worth to look maybe a little bit longer to find a better match from skills to personality that fit into the team, but not taking just the one with the highest scores in your math assessment or the highest scores in your coding assessment. I think that can be very important, because otherwise you might somehow slow down the whole team if there is someone in there, some person in there that does not really have the same type of spirit and the mindset of the team. Of course, everybody had the experience that you assessed persons in an interview, you had the good confidence that everything works, but in the end it turned out somehow that it does not really work. Of course, that's also something, and there you have to decide if you want to carry on and try to integrate, or at a certain point in time you might say, let's find another solution. Maybe in the organization, try to also support this person then to might find something different in the organization. But that can happen. So nobody is really secure and safe for judging the situation wrong, or somehow it turns out that people behave differently than you expected, or there has been some incidents in their personal lives or in the team's development, such that somehow the spirits and ways somehow diverge. I think that could can hit everybody, and you are not safe from experience this in a way, despite the fact that you put a lot of time into the selection process and have a clear idea what you think is very important. But this happens as well.
Yes, that's life, right?
Of course, yeah, and you have to be prepared for that. So I think that's very important for people leading teams, that they always somehow have to be in contact and talk and see what's going on actually. And of course, I was lucky. I had only these type of small teams. But if you are responsible for a large bunch of people, I don't know, that gets harder and harder, of course.
You were talking about the importance also of coding ability, having members of the team with that kind of profile. A question that's been on my mind since everybody got really scared of ChatGPT is the position of quant developer something that might be at risk of becoming extinct as a result of AI? And talking about it in the context of what you were talking about there, where is the more sort of, it would seem like an obvious thing if artificial intelligence generated code becomes more robust. It's a possibility, but can we talk about the nuances in terms of what makes a particular quant developer more special than just a regular coding jockey sort of thing? Should quant developers worry, and what's going to make them less worried in the context of how can they differentiate themselves?
So I think a quant developer is not only someone writing just a particular single algorithm, actually. I think it's more of having in mind the whole architecture of a certain library, or the interfaces, how things work together, and then using this knowledge of enhancing the library by building a new class, building new interfaces, and knowing really what's going on. So I like actually the idea of some software, some ChatGPT kind of thing, of maybe doing more boring things for the programmer. So for example, you have to integrate a new vendor system or a new database type into and make it accessible for your library. So to generate some text or XML files for certain trades or for market data, I think would be nice just to specify the needs just using words, and then something like this bot creates all the nice functionality, transferring certain database entries into XML files and make all the boring work for you in a way. But yeah, at the moment, I think quant developers really maintaining libraries, working also maybe with different types of programming languages, know about the things you have to take care of when you combine, I don't know, C++ libraries with other type of code for making interfaces to GUI applications which are not written in plain C++. I think that's something at the moment quant developers are quite safe actually, but maybe something like translating Python code into R, or Python code into C++ or whatsoever. Yeah, there might be potential of using that kind of bots. And as I said, I hope some of the boring tasks might be sooner or later being replaced by that applications in a way. But my experience, at least, is also in the financial industry today. People are seeking quant developers and quantitative analysts, knowing about the models, knowing about the markets, knowing about maintaining libraries, implementing stuff into the library, and so forth. I think, yeah, it's a rare skill at the moment. It is because yeah, that's what I learned from the students at university. They're currently more eager going into this nice fancy things like self-driving cars and so forth than spending, of course, their professional time in financial institutions, because I think they need somehow this new freedom and spirit of this of these new technologies. And in the financial industry, somehow, of course, it's regulated. It has to be regulated. And I don't know, people might not really want to be in this setup where a lot of things are really put in stone, how things have to be done, and what type of models can be used. They might be
interesting. So do you think that any major pay increases are going to be on the horizon to try and make up?
I don't know if this is all about pay. So I've talked to a lot of students, and they said they want to do something, say, meaningful. Either they want to do and apply their modeling skills into climate modeling, try to find out about optimizing certain processes in industry to make it more climate neutral. They want to build, I don't know, fancy applications like ChatGPT, like self-driving cars. So there are a lot of characters around. They're not thinking of money in the first place. I have the feeling. So just talking to the to students currently making conducting their master degrees or bachelor degrees. Of course, there are people who like to join the financial industry, and I think money is one of the arguments for joining the industry. But there are different types of characters. Some are the innovative guys, some are the guys who like to give back something, to improve somehow the overall quality of life, I would term it maybe, and make it sustainable and so forth. But also the people who like to apply their skills in quantitative finance. And one has to say quantitative finance was always a pool of having a lot of ideas from different fields and applying these ideas to certain quantitative problems and questions in option pricing, in hedging, and so forth. So a lot of different breed of people, being it statisticians, pure mathematics, physicists, and all these guys have contributed with fresh ideas to the field of quantitative finance. So it's something I liked, because you learn so much new techniques and ideas, and a lot of new inflow from different disciplines is in there, and there's still room for applying new and innovative techniques there, I would say.
Precisely. How do we imbue quantitative finance with meaning to the current generation? I think that this is something that needs to be communicated on college campuses in a different way, possibly. I think that, as you say, the heritage of quantitative finance represents the possibilities of the future, I would say, and that's a very important observation. Now, one of Espen Haug's favorite phrases was "know your weapon." And when it comes to programming languages, it seems like there seems to be a new programming language rearing its head every 2 months. What's your view on which languages are apt for what purpose? And is there anything new on the horizon that you view as interesting?
So I think the main weapon in quantitative finance is C++. So I think a lot of libraries are written in C++, and C++ skills are very essential, I would say. And I think if you are fluent in C++ in a way, I think it's not that hard for you to learn any other programming language. I think C++ is ubiquitous in the financial industry, but of course all the others like Java, like C#, there is of course Python making its way because of all the packages and the ease of getting up to speed in Python. There are, of course, some other potential candidates like Julia, because this is a very fast processing language in a way. It can handle tasks much faster than Python, and is also easy to learn. So I've experimented a little bit with these programming languages. Find them nice, but it's something, of course, you mentioned the heritage, and I think the heritage is for all the libraries, it's actually C++ code in a way. And I would advocate to learn really the programming language from scratch. So I learned C++ when I started. I'm not fluent in C++ anymore, by no means. So I can understand C++ code and read it a bit, but I think getting to speed and really programming C++, I would have to spend a quite decent amount of time to do that again. But it depends. So if you really aim for being a quantitative developer, I think this would be a very good choice to go with C++. If you are somehow using programming language as a kind of tool of just checking certain things, writing code snippets, not really maintaining libraries, I think Python is very nice. Statisticians, of course, they are advocating R, and there's always this competition, R and Python. I do not want to engage into that. I think both languages, they have their pros and cons, actually. But I think once you decided how to, or which type of language you want to use, then take this slogan from Aspen by heart and really learn the programming language. So not just gluing together certain code snippets from the internet and writing a Python program. So I think then you really have to know your weapon and learn the programming language, really, that you can apply it, be fluent in it. If you use a new package, really get into the functionality, really know what's going on. I think that's very important. No matter which programming language you choose, I think really getting into it when you want to apply it in real life, that's in research, would be important, actually. But if you want to have a great career as a quant developer in quantitative finance, I think C++ would be the programming language to go for, actually.
Exactly. Of course, we have to say that because we don't want to be excommunicated by Daniel J. Duffy either. So that's another strong reason to promote C++. Thanks so much for your time, Jörg. I would just like to wrap up finally with, what would you hope that that people take away from your talk at the conference? What sort of key message do you hope that they take away from that?
So I think the key message would be to see another angle or another aspect of the Black-Scholes Merton or Black-Scholes approach of pricing options, of the framework there, and thinking about how to adapt the key ideas. In my case, it would be the hedging, and apply it in a different setting, using statistical learning, for example, maybe incorporating other ideas like this indifference pricing ideas. So just seeing a certain angle of the contribution of Black-Scholes and Merton, and not just having the PDE and the Black-Scholes formula in mind, but all the aspects. And one aspect, as I said, is the idea of hedging and how one can use this basic concept in maybe in a different setting, using different methods, not only the ones which are currently established and to work very well. So that would be nice. And I would love to hear if anybody can apply the ideas for their real life applications, and maybe has some ideas for future research or collaboration or whatsoever. That would be fantastic.
Thank you very much, Jörg. And if you're listening in and it's not June the 14th yet, you'll be able to watch Jörg present at the Black-Scholes 50th anniversary conference presented by the CQF Institute. Other great speakers going to be there as well. We have got Paul Wilmot, of course. We have Emmanuel Derman. We have Robert Litterman, Laura Balotta, and a host of others. And hopefully some Eli Ayash as well. And we have hopefully some surprise speakers who are going to be announced in the near future. So that's on 14th of June. CQF Institute members attend for free. And of course, membership of the CQF Institute is for free as well. So you have no excuse. Thanks very much. Thanks, Jörg. Thanks so much.
Thank you for listening to QuantSpeak. Don't forget to subscribe, and do sign up to the CQF Institute for more insights into quant finance.